Okay, so I want to talk about recursion. And recursion is any method that calls itself. So inside the method, it will call itself. And with each method call, the problem becomes simpler. And there must be a condition where the method no longer calls itself. If this condition does not exist, there will be an infinite loop. The method will keep calling itself infinitely, and there's no stopping point. So let me give you an example here of factorial. Notice this method returns an int. It's called factorial. It's meant to calculate factorials. And down here, I call itself. So I call factorial of n minus 1. And notice that there is an ending spot. Like if n gets to 1, I know that 1 factorial is 1. So this is kind of where I want it to stop. Now let's look at how this method works. Factorial 5, it's going to check here. Does 5 equal 1? No. So it's going to return 5 times factorial of 4. And it's going to try to calculate factorial of 4. Does 4 equal 1? No. So it's going to return 4 times factorial 3. And then we have factorial 3. Does 3 equal 1? No. So it's going to return 3 times factorial 2. Then we have the case where does 2 equal 1? No. So we're going to return 2 times factorial 1. And we've gotten to the end here because we know what factorial 1 is. If n equals 1, we're going to return 1. So I know this is 1. So I calculate 2 times 1 is 2. This is factorial 2. So this 2 gets moved back up here. And I get 3 times 2 is 6. And that's factorial of 3. So this gets moved back up here. And I get 4 times 6 is 24. And finally, 5 times 24 is 120. So now let's write a couple factorial methods. In our notes we did this. I'm going to write this print triples method that is a recursive method here. So again, any recursive method calls itself. And printing a triple is to printing multiples of 3. So the first 4 triples would be 12, 9, 6, and 3. So I kind of start with a stopping point, and I know that if n is equal to 0, then I just want to stop. In this case, I'm just going to say return. I'm saying return here because it's a void method. If this was an int method, I would be returning some value, some int value. If it's not, then I want to print the triple. So I'm going to system dot out dot print, and I want to print n times 3 plus a comma, and the next line, this is not recursive yet, I need to call print triples of n minus 1. So my n, just like before, my n slowly gets lower with the n minus 1 until it reaches the stopping point, which is 0, and then it will run. So let's go ahead and check this out. I can just run this print triples method from here, and let's say I want to print the first 5. I just type OK, and there it is. 1, 2, 3, 4, 5 triples. Let's run it again. I'm going to put 8 in there. 1, 2, 3, 4, 5, 6, 7, 8 triples. It prints all 8 of them. Now I'm able to run it from here because I made this method static. Static means I don't need to have an object of that class to run it. So I can I can run this method. Hey, one more we're going to do. We're going to do, we're going to write the factorial recursion method here. We just saw that in our example, but let's see if we can duplicate it. I know that my stopping point here, if n is equal to 1, I know that 1 factorial is 1, so I'm going to return 1. Otherwise, I'm going to return n times factorial of n minus 1. Oops, it's called factorial recursion here, so let me copy, paste that, and we'll run that again. I'm going to run factorial recursion. I'm going to put in 5 because I know that's 120, and there, we're done. Hey, that's it for recursion. If you still don't understand, you can ask me more questions.